Exponential functions. What we're going to be looking at is something called an exponential function. And what we've changed it is in the fact is the variable is going to be in the exponent. And it says where x is any real number, so it's a number on your number line, not imaginary, and b is greater than 0, but b does not equal 1. Now why? Why does it tell you all this? Why do we need to know those restrictions? Let's just kind of think through this process. If b were equal to 0, that cannot happen. Because if b is equal to 0, that would give me some 0 to the x, and that doesn't exist. If b is positive, that's what this is saying, b is greater than 0. Let's think through if it's not positive. That means we could possibly have a negative b being raised to some 1/2, which is a square root, which gives imaginary answers. And since x is any real number, it could be a 1/2. So b has to remain positive. Lastly, why can b not equal 1? Well, that means I would have 1 to some x and 1 just as constant. And so this stuff here at the end is not just there for decoration. It does have a purpose because it's defining those b's so it behaves and acts correctly. Evaluating an exponential function. Let's start looking at how we can evaluate these different things, and how we're going to look at that is we're going to start with a pretty basic exponential function. We're going to plug in some different values and create that table, and then look at the graph and then bring it all together with an explanation. So what you have to remember is our variable, or x, has now moved into this exponent. So when I'm plugging in all these different x values and saying let x equal -3, -2, etc., they are going to be exponents. So this would be 2 raised to the -3. Now, if we remember, with negative exponents, that means it can move to the bottom, which gives me 1 over 2 cubed, or 1 over 8. Now, you can just plug this in your calculator. Let me show you what that looks like. So in your calculator, this is just your on-screen calculator you have under each homework problem. We're going to say 2, then we're going to raise it by using this a to the b button to the -3 power. You can see over here, if I hit my little toggle, that gives me 1/8. And you can see that we were plugging in the different values. So while we have our calculator up, let's just go ahead and do that. This would be 2 raised to the -2. Again, I can hit my toggle. That shows it to be 1/4. 2 raised to the -1 gives me 1/2. 2 raised to the 0 gives me 1. 2 squared, and then 2 cubed. And so you can see as we're looking at these negative values, we were getting fractions. We plugged in 0 and we got 1. And then we also did our positives, and we got 4 and then 8. So I just want to kind of acclimate you to this on-screen calculator. Make sure you understand where those buttons are. Now let's fill in those values we just got from the calculator. So we had 1/4, 1/2, 1, 2, 4, and 8. So if I take these values and I come over here to my graph, I can plot those. So at x equals -3, we're at about 1/8. And then at x equals -2, we were about at 1/4. A little bit harder to graph, but it'll give us an idea. 1/2, 1, 2, 4, and then 8. So looking at this first curve, this gives me an idea of this being our 2 to the x curve. Now we can do the same thing with another one. You can see that this is g of x equal to 2 to the -x. Now recall, when we're working with something being raised to a negative exponent, just like we kind of mentioned in that first value, that's the same thing as 1 over a to the x. Moving this to the denominator gives you a positive exponent. These are reciprocals of each other. So what we're going to do is, when we start looking at our next situation, When we go to plug in, so here's our variable. This is going to give me 2 to the negative 3, which is just 2 cubed, which we already saw that to be 8. This gives me 2 to the negative 2, which is just 2 squared, which is 4. You can see these are the same values, but they've been flip-flopped. So it gives me 1, this is 2, because that's 2 to the negative 1, so just positive 2. This gives me 2 to the negative 0, which is just 2 to the 0, so it gives me 1. You can see I'm just following the trend of these numbers here, that those negatives are canceling each other. So I'm going to get 1/2, 1/4, and then 1/8, just by going through those values. And so if I go to plot this one, well, at -3, it's at 8. At -2, it's at 4. At -1, it's at 2. And you can see my trend is just that this thing has been reflected. Now, I'm not going to make a ton of these tables through this different section, but I just want to start with one exact graph and give us an idea of what's going on with these different functions. And there are some characteristics we can pull out of this by looking at this graph here. We can see if we're looking at the domain, we're going to go back to generic, b to the x or b to the negative x. The domain of this, remember domain is all possible x values, would be negative infinity to infinity. The same is true even when it flopped over and it turned red. There was no x values we didn't use. We used negatives, we used 0, we used positives. The range, which is all your possible y values, you can notice it stayed in those upper two quadrants. So that's from 0 to infinity. Now we didn't get a value of 0, but we got real close if we kept on going 1/8, etc. The y-intercept on both of these was 0, 1. That's where it's crossing the y-axis. The first function was an increasing function. We can see reading it from left to right, it was going upward. The second one was a decreasing function. And then what type of function is this? Well, these are both one-to-one functions. Remember that when we were looking at that term of function, one-to-one function means it's going to pass the vertical line test and the horizontal line test. Now we can go forward and we can even look at what some transformations are going to look like compared to this. And we've looked at transformations before, but this will be in relation to what we were doing with these exponentials. So before, if we had it plus or minus the number outside of our function, we knew that if we add it, that moved it up. If we subtract it, that moved it down. Well, with these exponential ones, the same is going to be true. If I had f of x, and we'll go back to our other equation, 2 to the x plus 1, this would mean by this plus 1, it would be up 1 unit. We've also looked at transformations, looked at when we add or subtract inside of the parentheses. It did the opposite of what we think. So left and right. Positive moved us left, negative moved us right, where it was the opposite of what you thought. So how does that look in this exponential realm? When you're looking at, say, f of x equal to 2 to the x plus 1. So adding that 1 up in the exponent means I'm going to move 1 unit to the left. What does this negative on the outside do? Well, remember on the outside gave us a reflection across the x-axis. So in an exponential, that means I would have f of x equal to negative 2 to the x. And then when we had the negative on the inside of the variable, that was our reflection across the y-axis. And you can see that looks a little bit different. We just saw that in that previous example. That would mean we have f of x equal to 2 to the negative x. And we could see that those values, it just reflected across that y-axis. So let's look at another graph and take that into consideration. This says, draw the graph of f of x equal to 6, negative x minus 2. So the first thing that we need to do is we need to figure out where is on this graph. Because when you're graphing this in the online homework, you're going to have to use your exponential tool and graph 2 points. So what we want to do is we are going to recall some things that we know about exponents. We know that if we had a to the 0 power, it would give us 1. Anything to the 0 power is 1. So what we're going to do is we're going to create that. So we're going to say, well, looking at this 6 to the negative x minus 2, when is negative x minus 2 equal to 0? That sets me up for a small equation to solve, so I could add this 2 over. Gives me negative x equal to 2 and divide by negative 1. So x would be equal to negative 2. So that when I plug negative 2 right here in for this x, looking at f of negative 2, that would be 6 minus negative 2 minus 2, which is 6, 2 minus 2, or 6 to the 0 power, which gives you 1. So when my x value is negative 2, my y value is 1, and I could plot that point. So let's see, we can go over negative 2, 1, and there's a dot. Now you can see that relates into our shift, because if I take 6 to the negative x minus 2 and I factor out a negative out of that top, that would give me negative x plus 2. So that was the left 2 units we would expect, because typically we have a point right here at 0, 1. So you can see that this has been shifted to the left 2 units. Then the other point that we can grab, if you recall, when you have something to the first power, it just gives you that base back. And so what we want to do is set our problem up again and say, okay, what about when negative x minus 2 equals 1? Solve this out, just like what we did before. So it gives me negative x equal to 3 and divide. So it gives me x equal to negative 3. So again, saying when f is negative 3 in this problem, that gives me 6 to the negative 3 minus 2, which is 6 to the 3 minus 2, or 6 to the first. So when x is negative 3, y would be 6. So again, I'll come up here and go to negative 3, 6, and I can put a dot. Now, once you have 2 points, using the online tool, you'll be able to graph it. If we wanted to, though, we could just make a table of values like we've done before, looking at x and f of x values. We could look at negative 4. I'm just going to plug that into my equation. That's 6 to the negative 4 minus 2. That gives me 36. Just use your on-screen calculator to help you with that. It's a little too high up to graph. Back if I plugged in negative 3, again using my on-screen calculator, that gives me 6. Or you can see from step 2 we got that. We know at negative 2 it's at 1. At negative 1, we plug that in, we get 1/6. And at 0, we get 1 over 36. So just to give us an idea of some other points, let's see, at negative 1, it's about at a 1/6. And at 0, it's really close. So our function would look something like this. And you can see in regard to that original graph, it does have a reflection, and then it does have that shift over. But I just want to kind of take you through that thought process on how I was getting some points, so that when you go to graph into that homework assignment, you'll be able to do that. Looking at the next part here, we can see that we're going to be looking at evaluating exponential functions with and without a calculator. So let's look at an example. Let f of x equal 5, 3 to the x plus 1. Evaluate f of 2 without using a calculator. So I know this should be a really nice number I should be able to get, because I don't have to use the calculator for this one. So f of 2 means I'm going to, everywhere I have a 2, you can see my x was there, means I'm just going to plug in 2 for x over here. So it gives me 5 times 3 to the 2 plus 1. So it gives me 5 times 3 to the 2 plus 1 is a third power. And 3 to the third power, because remember, when you're working through this, you want to work with order of operation. So please excuse my dear Aunt Sally. So we're going to do parentheses and then exponents. That's why I did that exponent up there of 2 plus 1. Then we're going to do this exponent of 3 cubed. So that gives me 5 times 27, giving me 135. So you do need to remember your order of operations with this. Next one, let f of x equal 2 to the 2 times x plus 3 to the x plus 1. Evaluate f of negative 2 without using a calculator. So I should have a really nice number here. So f of negative 2, be careful with that negative. That'd be 2 times negative 2 plus 3 to the negative 2 plus 1. I'm plugging in here for x and here for x. So it gives me 2. Let's see. Negative 2 plus 3 is a positive 1. And then negative 2 plus 1, that's a negative 1. Well, 1 raised to any power is just itself, so it's just 2 times 1. Now, when you're working these problems without using a calculator, if you're like, I'll just use a calculator, and then you get some crazy fraction, like crazy decimal, then you probably didn't work it correctly, because I'm not going to get those decimal numbers without using a calculator. Let's look at this next one. It says, let f of x equals 8 times 1.2 to the x minus 5. Evaluate using a calculator, round to 4 decimal places. And so f of 3, again, we're replacing x everywhere in the problem with our new value of 3. So it gives me 8, 1.2 to the 3 minus 5. Now, I might want to go ahead and clean that up myself. That would give me a negative 2. And then by all means, I'm going to have to go to my on-screen calculator to help me with that. So let's look at what that looks like. So we want to plug in everything we just wrote down. So I'm going to have 8, parentheses, 1.2, close parentheses. I'm going to use this A to the B button to give me that exponent. And then I'm going to plug in my negative 2 here. Now you can see that gave me a decimal number. It does say to round to 4 decimal places, but if it said an exact answer, I could click on this toggle and that would give me the improper fraction. But again, we're looking at using the 4-digit rounding. And so I'm just going to take this number. And so that means my final answer would just be 5.5556. So you can see the on-screen calculator is going to be very helpful. So we'll just write that in here, 5.5556. Do you make sure you're rounding correctly? This leads us into another item that we need to learn about in working with these exponential functions. It's known as the natural E. E all by itself, so just E raised to the first power. This represents the number 2.718281828459045. Now, that's not something we have to know, but I just want you to recognize that E is not a variable. It is not X, Y, anything like that. It does represent a number. And so things we know about E, it is an irrational number. It's similar to pi. You remember working with pi maybe in grade school, 22/7, 3.14, things like that. So it is a symbol that represents a number. And what it is, it's found in science, nature, and finance. And we'll see this in some examples to come. And so we're going to be working with this E, what that graph looks like. You can see I have it graphed here. F of x is equal to E to the x. It is an exponential function. You can see it kind of flatlines, then jumps up really dramatically, just like we were seeing in those earlier examples. So just to kind of work in and ease into working with our E's, first thing I'm going to do is I'm going to use this example here. Use a calculator to find E to the negative 0.5, round to 5 decimal places. So I'm going to show you where this button is on your on-screen calculator and help you with that. So you can see I have this pulled up and I can work this a couple of different ways. I can either use my keyboard and just use a lowercase e. I can come over here and I can hit the ABC button, and I can use the E on their on-screen keyboard. And you can see I'm already seeing 2.718 if I'm just looking at that. Or when I look at the function button, you can see over here to the right, not only do I have an E button, I also have an E raised to the X power. So it's going to automatically give you that raise up into the exponent. Now in our problem, we were looking at E being raised to the negative 0.5. And so I am going to go ahead and just use this button that says E raised to the X. Go back into my main. I've got too many there. There it is. And then I'm going to put my negative 0.5. And you can see I'm making my problem in my on-screen calculator look just like the problem that was given. And so I'm able to get that value, and that's 0.60653, etc. Now it wanted me to round to 5 decimal places. So let's look at what that's going to look like. So we had e to the negative 0.05 plugged in our calculator. We got 0.60653. When I'm going to 5 decimal places, I just go one step more. Whenever you're looking for the 5th one, you look at the 6th one. If it's 5 or more, you remember, we round up. In this case, it's just 0. So that means my final answer would be 0.60653. And you do have to round appropriately when you're working these problems, okay?